Okay, we're recording. Okay, so we're going to go and do a run through of the tutorial. So to get started, everybody should have already set up the development environment, like WSL2, Docker, ROS, all that good stuff. And then gone ahead and cloned the repository to their computer somewhere. So if you followed the tutorials exactly, I think it'll just be in your home directory, which you can get to just by running cd. But for me, it's in a slightly different spot. And so if you put it somewhere else, just go there. And then inside of that, you're going to want to navigate into the Docker folder. And so that's so that you can run the Docker environment. So I'm going to give everyone just a second to do that. Okay. So once you're there, like you'll know if you're in the right directory, if you list the contents and you see like all these scripts. So we're going to run the one script, Docker run. And so what this is doing is it's starting up a new virtual machine instance on your computer. So it's taking the image, which is sort of like the contain whenever it's not running, and turning it into a container, which is the language that you use whenever it is something actively running. And then it's changing your terminal so that now you're speaking to the container instead of your regular operating system. So you can see that for me, I used to be at like James at desktop and then some numbers, and now I'm James at ARC dev. So my terminal is now inside the container. And it's also switched to black and white just as another way to see that, I guess. So make sure that you're in the container for this next part of the tutorial, because it's not going to work just in WSL2. And then one other thing just to note is that whatever directory you have everything in to begin with, so I have mine, like this whole list of things, I put it inside like a snake tutorial workspace is what I called it. It's going inside the container, it's going to mount that as catkin workspace. So if I list, that's catkin workspace, and that's the same directory I was in. It's basically like a hyperlink to get from one to the other. Okay, just in chat real quick, I see some people are saying Docker run isn't working for me. So I'm just going to go over the exact syntax to run that is you're going to use a // and then docker-run.sh. And that's going to require that you've already built the container. So if you haven't done that yet, use a /docker build. And as long as you aren't logged in as root, that'll go ahead and work. And then you can run Docker run after that. Okay, so now that we're inside, just real quick before we move forward, we want to double check that X forwarding is working. So this is going to let us run graphical programs inside the Docker container and then bring it out onto our desktop so that we can see it. So I'm going to go ahead and run it. And then just, do you guys all only see one screen of my computer, right? Or do you see both of them?
Oh, we can just see one.
Okay, so you don't see the XIs yet, right? You're seeing the one with the terminal?
Yeah, we can just see a terminal.
Okay. Yeah, so the XIs popped up on my other monitor, which is why you didn't see it till I dragged it over. But you should get a little thing that looks like that. And as long as that works, then everything else is going to work here in the tutorial. And if that isn't working, you probably want to retry running whatever X server you're using, like closing that and relaunching it. Or you might want to shut down WSL2 and restart it. Or you could just reboot your entire computer sometimes. It's kind of finicky. So just whatever you have to do to get that working before you move on. Okay, so now we're going to keep going. So just as like a walkthrough of what we're going to be doing here is we're going to be learning ROS using Python, and it's all going to be taking place inside this Docker environment. So our ultimate goal is to end up coming up with our own little policy to control the snake game. So I'm going to bring that up over here. So like this is the classic snake game, like you're trying to eat apples. Every time you eat an apple, your tail gets bigger by 1, and if you run into the wall or yourself, you die. So that game is already implemented in ROS, and we can think of that as a simulation of a real robot. because the way that we're using ROS and the commands that you're giving to the snake are actually very similar to commands that you give to physical robots. So we can, rather than just thinking of this as a video game, we can think of it as a simulator for a real robot. And so the skills that you're learning here are all very relevant. So to sort of get started, we can go ahead and run. Here, let me move on to the next one. We can go ahead and run like the existing snake simulator that we've built in ROS, just to see how all that works. So now that we're in Docker, I'm going to move inside the Catkin workspace. If you haven't built it yet, you have to do that now. So Catkin build. And this is, if you have C files, this will compile them. For me, it ran very quickly because I've already done it. If you have Python stuff, it's not really compiling anything. It's just making some links for you. But it's basically compiling. And then once you've built everything, you need to source it. And so this is so that your computer knows where to find everything whenever you try to launch stuff. So the command for that is source, and then wherever the stuff is. So it's devel/setup.bash. If you're using a different terminal like Zeesh or something like that, use one of the other ones, but I'm using bash. You should be using bash unless if you did something special. To repeat the Catkin command, so you have to be inside the Catkin workspace. So if I move out, you can see that's the workspace. I'm going to navigate into it. And now I'm inside of it. And now I'm going to run Catkin build. You may see tutorials talk about Catkin make, and this is running something equivalent, but we're going to use Catkin build for the club. And then if you've never, I'm going to go ahead and do something real quick just so I'm going to use Catkin clean. You don't need to run that. And so this is what it looks like if you've never run it before. It's just doing the exact same thing, except it takes a little bit longer. Okay, I'm going to assume that everybody's made it to that step now. Okay, so it even gives you a little note there saying that the packages have changed and you need to source the setup files to use them. So again, the command to do that is source devel setup.bash. And one of the things I'm doing here is I'm using tab completion. So I do not have crazy fast typing fingers, but instead I just get like the first 2 letters of each thing and then I hit tab and it'll act as autocomplete. So that's really nice sometimes if you want to save a little bit of time typing, or if you don't necessarily know the full name of something, you can just keep hitting tab and it'll give you options. Okay, so then once you've sourced that, you can go ahead and run things. So I'm going to do like what I just said now about if you don't know the proper name of everything, you can use tab completion to help you, because I don't 100% remember the name of what I'm trying to run here. So the command is ROS launch, all one word, ROS-LAUNCH space. And then you want to give it the package name. So that's going to be SnakeSim. And you can see that was one of the packages that we just built now. And then the last part is going to be the launch file name. So I don't remember what that is. I think it's snakesim.launch, but I can just hit tab a couple of times and it'll give me all the options. So there's a snake node, a snakesim, and a snakesim rviz. So I know that the snakesim.launch one is what I want. And again, I just had to hit .l and then hit tab, and then it figured out the rest. So once you hit enter there, it's going to run it. It's going to open up a GUI. So I have to drag that over to this window so you can see. Yeah, and GUI is a graphical user interface, GUI. I pronounce it GUI, as do a lot of people, I think. Daniel is making fun of me in chat. So this is going to bring up some very simple controls in order to move the snake. So in the game in my browser, like you use the arrow keys. But here, since we're trying to make it similar to what a real robot uses, it's a little bit different. So you give it like a forward velocity, and then you give it like an angular velocity. And then typically for ROS, everything is going to be specified in SI units. So it's meters per second and radians per second, as you can see the graphical tool, the GUI, like has that labeled for us. And so like the head of the snake is marked out in a different color. You can see I just ran into a wall because I'm not very good at this. And then the body of the snake, you can see that it got one extra segment whenever it consumed the apple. And then the apple moved into a random new spot. Okay. And actually, I may as well give a little demonstration. So this is a turtle bot. This is a Waffle Pie 3, I believe, is the specific name of it. And so this is like a platform that you can just buy. I don't know exactly how much it costs. I have it here just for some research I'm doing with a professor. But what's fun about this is this uses the exact same message in order to move the robot. So it uses the exact same twist message, which is what we're giving the snake, where you give it a forward velocity and you give it an angular velocity. And it has a little Raspberry Pi on it that's going to be decoding that. And then it sends it over to a motor controller. And then it's got two little motors here. And it'll use differential steering in order to execute that. So just another fun note. Someone's asking where the recordings are posted. This is going to go on the club YouTube channel. Okay, so I'm going to keep this running in the background. And I'm going to open up another thing to show you something. So if you're like, open up a new terminal, I can hit Control-Shift-T to do that. So I'm going to go ahead and start the Docker stuff again. So you can go ahead and use the script. Or you can use the command, just like the regular Docker command. So this is how you would do it if you don't want to use the script. Or you can do the exact same thing if you use the script. So here, I'm going to cd into source, snake tutorial workspace. And I can use /docker join. And all that script is doing, it's just doing the exact same thing I did there. But sometimes, like, I don't know, there might be a few spots during this where like I speed things up and run it like that instead of navigating into the spot. So anyways, so now that you're here, there are a bunch of like fun tools that ROS comes with. So one of them is ROS topic. So this is going to tell us everything that's currently moving in the ROS network. So this is giving us all the different topics. And so you can see that's talking about snake command velocity, and we can see it there. And if we want to, we can do ROS topic echo. And we can see exactly what this thing is spitting out. So linear of 1.273, and that's what it's doing here, and then 3 radians per second. So those are two command line tools that could be really useful. There's one last one I'm going to show you. RQT graph. Okay, there we go. And this is going to pull up a visual representation of the ROS network. Because ROS, even though it stands for Robot Operating System, it isn't actually an operating system. It's just a bunch of packages that you install onto Ubuntu. Or you can sometimes get it on other operating systems, but Ubuntu is like the main one that it supports. And ROS is really more of a framework than an operating system. It's a tool that lets you define like a common language for running programs and having them communicate with one another. So like the main idea of ROS is that you have multiple nodes running. So right now we have the snake controller and we have the snake node. So this guy, this is the snake controller. And this is the snake node. And you can see that they're talking to one another through this topic, the snake command velocity. There we go. So you can see that's the topic name there. And so whenever we actually open up the source files for stuff later, all that's happening is we wrote a Python program. You can also write a C++ program. And those are the two main languages ROS supports. And it's publishing something to this topic called snake command velocity. And then the snake node is subscribing to that topic. And so two completely different people can have written those nodes. And as long as you agree on what that message is going to contain, then it's really nice that it sort of defines your interface for you. Like another upside to it is that everything is modular. So we can get rid of this snake controller, which is what we're going to do during this tutorial. We're going to make this message come from a different source. And the snake node, which is like the simulator over here, does not care. As long as it receives a valid snake command velocity, it's going to execute it. And the whole system can be modular like that. And if we mess with this, you can see like there's some other little views that you can do with it. So there we can see how things are namespaced. You can do some of this stuff. And so we can see that there's actually a lot more going on in this network than we looked at originally. So the snake controller is publishing the commanded velocity, and then the simulator is actually publishing a few different things. It's publishing like whether or not the snake is active, which is Boolean, the position of the snake, which we'll need later on, the position of the goal, and the current score. And then if you want to, you can get all this same information through the command line. So you can use ROS node list, and you can see those nodes that we were talking about earlier. And you can do ROS node info, snake node. And now it gives us basically the same information we just saw. You can see that it's subscribing, or sorry, it's publishing, meaning this information is originating at this node and going outwards. Like, is it active? And you can see that's a Boolean, the goal, and you can see that's a point, the pose, and that's a pose array, which is like a list of locations and orientations, the score, which is just an integer. You can see it's subscribing to the commanded velocity. And then it's also got this service called snake reset. So I'm going to actually demonstrate that here in a second. So you can do ROS service pub, I believe, or actually it's call. And again, this is tab completion coming in handy. So I'm just hitting tab and it's going to give me all these different things. So yeah, with snake reset, and then again, just hitting tab. The reset earlier we saw, okay, it didn't tell us, but it's an empty one. So I can just run that. And then boom, everything resets. So you can use that if you want to give steering the snake another whirl. But that's just a quick demonstration of some of the different command line and graphical tools that you can use when debugging. That's going to help when doing this tutorial. So I'm going to go ahead and kill this off, and then we can get started writing some Python code. And I'm going to keep this second window open for a little bit longer. Okay, so I've got the tutorial pulled up on the left side here, and I'm going to start making my way through it. So right now we're getting started with creating a package, which is the second document. I went ahead, everything I did previously is kind of before that. I see someone's asking, how do you open the second window? So if you're using Windows Terminal, which I recommend, if you're on Windows, that is, then you can just hit the plus over here. If you're on Ubuntu, you can hit Control-Shift-T, or there should also be a plus. But anyways, or if you're doing it like through the base WSL, you just have to run another instance of it. But then once you have...
I want to say sometimes if you hit the plus, it might open, at least for me, like it just opens a normal command line. So I had to hit like the drop down and select Ubuntu, but it depends on how you have it set up.
Yeah, so you might have to hit the drop down and choose what you want here. I've got mine set up so that Ubuntu is the default. And then once you have that open, you're going to navigate into that same Docker folder that you used to launch it earlier, and you can use Docker join. Okay. So I'm just reading through the tutorial really quickly here to make sure that I'm using the same commands and everything that it wants you to, just so everything's more consistent. So a little bit on the directory structure, I kind of glossed over earlier. So you've got your workspace, and then inside of that you have, so we already talked about what devel does, and that's an abbreviation for development. And so that kind of has the stuff that you can source to run it, and build, that's going to have like artifacts from running make. And then source, SRC, abbreviated there, is where you're going to keep all your source code. So you can see that I just have one package here. Sorry, I just have one folder here, ARC tutorials. If I move into that, I actually have two packages inside of that. So we had Snake Tutorial and Snake Sim were the ones we looked at earlier. There's also a clock tutorial in here, but we've got a little file in there so that it doesn't compile, because it's we're not currently using it or anything. So to go ahead and create a new package, we're going to get just right into the main source directory. Although you could do it inside another folder if you want everything to be tracked inside the same GitHub repository. But we're going to navigate into source, and I'm just going to go ahead and copy the command from the tutorial. And then I'll talk about what it's doing. So we're using catkin create package. And again, like earlier, I talked about catkin build and catkin make, and that's the tool that we're using to run all this stuff. So that's just the command. We want the package to be named Snake Controller, and then this is just giving it a bunch of dependencies. And that's purely just for documentation's sake. It doesn't actually matter since it's not compiling with C. Okay, so that all went ahead and got built. And now I can cd into Snake Controller. And if you've already sort of like attempted the tutorial and you want to sort of like redo your stuff, you can go ahead and just delete that directory, or you could move it and call it something else. Probably the best thing to do is to add a catkin ignore into it. So you could cd into like your existing one that you want to ignore, and then you would run touch catkin ignore, all caps with an underscore, and then catkin's going to ignore it. I'm going to go ahead and delete that for now, because I do want to use this. And then you could go ahead and just move that folder, like rename it to be something else, and continue along with the tutorial. Or the other thing you could do is whenever you do in catkin create package, just give it a new name like Snake Controller 2 or Snake Tutorial, or just anything that isn't already in use. Okay. So yeah, in the tutorial next, we're going through and we're modifying some of these initial files it gives us. This isn't super critical to right now. I'm going to go ahead and open up a new window using VS Code. So give me a second here. Okay, it's taking a second to get started. It's having trouble finding the remote, it says. Okay, well, while that's chugging along, I'm going to go ahead and just show you some of the stuff using the terminal here. So if you go ahead and run cat, you can spit all this stuff out, and you can see it gives you a lot of boilerplate things, like stuff is commented out. And if you're using like a C++ package, it's really important to get this stuff right. But for Python, a lot of it really doesn't matter. So we have something in the tutorial for you to go over and copy paste. So this still isn't working over here. So I'm going to try one extra thing. Okay, there we go. Okay, and then, sorry, I probably should have showed what I was doing on screen. No, that's fun. I think I just went ahead and crashed. Okay, so I can actually show you what I did on screen. But you're going to go ahead and click down here in the bottom left and then Remote WSL New Window. And then once up and running, you can hit Open Folder and just navigate to where it is. And now you're navigating in your regular WSL2 instance, not in the Docker container. So remember where you put that. Okay. So Snake Controller is the thing that we just made. And if I go ahead and open up CMake lists, you can see all of this stuff. If you want to format it, I think there's like a way to tell it CMake. Okay, maybe not. But we can go ahead and we can just copy over all of the stuff in the tutorial just to make it shorter. And this is sort of like something that you can do for every new one that you create using Python. And you can give it like a version, you can give it a name, you can stick like your email here. So I can do baxter26@purdue.edu if I wanted. You can do all sorts of fun stuff there. All the dependencies that we talked about earlier are there. I'm going to move on from this just for the sake of time. Actually, I'm sorry, I pasted the package XML in there. Okay, so that's the package XML, and that has all that content. And then the CMake is more, it's similar to a make, it's basically a make file. And so for C, it's really important. For Python, this is all that you actually need. You just have to define a project really, and then you have to tell it to go ahead and make everything. So it's pretty simple. We're now going to go ahead and create the directory structure. So you can see that it kind of gave us a source, but we're not going to use it because we would use that if we were making stuff in C. So instead, we're just going to make some new folders. So we're going to make one called nodes, and that's where we're going to put our Python scripts for each node. We're going to make one called launch, and that's where we're going to put launch files. So those are sort of like XML files, similar to the package XML, and it's sort of defining what stuff to launch. So earlier we used that with the ROS launch command, and that's actually the only two folders that we need. Okay, we can go ahead and keep moving. There's some stuff about making a Docker commit and sourcing stuff automatically. I'm not going to do that for right now, just so that it's more repeated, like how you need to source your stuff, but you can do that on your own time. Okay, so let's get started with the heading controller. I'm going to go ahead and actually bring this over here so you guys can see that. But this is going to be using something called closed loop feedback. So essentially, we have some state that we want the snake to be at. So that's like the desired heading. I guess to sort of back up just 1 second, we sort of have this somewhat complicated task where we want to have the snake like autonomously find the apples and eat them and keep on moving. And that's a pretty big challenge just to write in one chunk of code. So sort of before doing this, like I sort of went back and thought, well, how can I break this down into smaller pieces? And so this is something pretty common in robotics, is to level the different layers of abstraction. So at the first thing, just controlling the snake, I want to have something that can point the snake in the direction that I want to. And then I'm going to stack additional things on top of that. So on top of that, I'm going to, once I can make the snake point in a certain direction, then I can make the snake go to a certain point. Because what is going somewhere other than like looking at it and going forward? And that's a lot easier to do than just starting from scratch saying go to a point. And then the very last thing we're going to do is we're going to write a little thing that takes the goal and it tells it to go to that goal. So we're kind of breaking down the problem into smaller tasks. And unfortunately, I don't really have a picture that shows how all that works together. You're just going to have to wait until the end to see it. Actually, I suppose I could run. I may do something in just a second to demonstrate that. But for this one specific piece, we're going to be using closed loop feedback. So we're assuming that we have some higher level piece of software that is able to tell us what direction we want to face. So we bring that in, and then since the simulator tells us exactly where we are and what we're facing, we don't have to worry about building some system with sensors to know that. Instead, we're just going to go ahead and subtract those to get an error. And then we're going to have our little node here is going to do something with that error, where it's trying to make that error go to 0. And then in order to make that error go to 0, it's going to tell the snake to move in a certain direction, and then the snake's going to execute that through the simulation. And more specifically, we're going to be using something called a bang bang controller. If you've heard of a PID controller, that's another thing that you could use here. Or you could use like a lead lag controller if you wanted to get technical. Or you could do all sorts of stuff. You could have like a machine learning algorithm here, but a lot of that is really overkill for what we need. So a bang bang controller, all that it does is you tell it either like you just have two absolute values that you go back and forth. So your output is going to look like a square wave. And so all that you say is if, I want to face in this direction and I'm going here, we're just going to say spin in this direction as fast as possible. And if the opposite is true and you're over here and want to go there, we're going to say spin in that direction as fast as possible. And if you're facing right at it, it'll output 0. And so if you were to actually implement this in the real world, you might have like a lot of oscillation right whenever you get to that 0 point, because it's going as hard as it can and then back and forth. But we're not worried about that for right now. So I'm going to go ahead and move this over to the side. Okay, I see someone asked, yeah, how did you open all the code? Did you get that figured out? Okay, cool. And I'm going to real quick just demonstrate how I said earlier, how we're going to kind of have these levels of abstraction. Like I realize like right now we're like already 40 minutes in and like I'm basically nowhere. So this is going to go much longer than the 60 minutes I originally planned. I think it's going to go more like 90 minutes. But as long as that's okay with everyone, I'm going to keep moving. Or we could break it up into multiple things if it really goes long. But I think we'll still be good for 90 minutes. So we already have everything sourced, and you guys can run this on your computer too. So ROS launch, and so the snake tutorial, it already has all this code in it that we're about to write. So you can just run it. So that's the command, ROS launch, snake tutorial, snake.launch. And if you go ahead and run that, it's probably going to open up on the wrong monitor. And you can see this is the system that we're going to write by the end of this. So it looks pretty cool. Like you would never guess that this is actually using like some really simple controls behind the scene. Okay, maybe at that instance you would realize that it's doing something fishy. But I guess the lesson there is like, you can have some really like complex looking behavior just from some really simple stuff stacked together in funny ways. So I'm going to go ahead and open up that same graph that I did earlier, rosrun rqt graph. Gave me some libgl error, but that seems to be okay because it's here, isn't it? Okay, so that's probably the best view to look at it. So this is how everything's going to work together in the very end. But you can see this is the simulator here. So this does a nice job of highlighting everything for you. So you can see blue stuff is stuff coming in that it's subscribed to, and green stuff is stuff that it's publishing. So it's receiving this commanded velocity, and it's getting it from this guy, which is the heading controller that we're about to write. And that's getting a heading from the position controller, which is something we're about to write. And that's getting a position from the goal controller, which is something we're about to write. So this is sort of that idea that I mentioned earlier, where we're going to go ahead and take this and have multiple levels of abstraction in order to break down a somewhat complicated task into really a couple simple ones. And you can see here that multiple things are using the pose, because these are actually going to be two closed loop feedback systems operating independently. I'm going to go ahead and reset this. Just so you guys can see that again. But this is what we're going to end up writing. And you can see it dyed in the wall there, which is fine because we're trying to just write something really simple for the sake of the tutorial. But sometimes you'd be surprised. It actually ends up being really successful. Okay. Okay, so I'm following along with the tutorial now again. So I'm on number 3 heading controller. So we're inside this snake controller space, and we're going to move inside of the nodes folder. And then we're going to make a file there. You can either do this through whatever IDE you have set up. You could just simply do new file. I'm going to show you the command line way just because that is going to be less intuitive than right clicking. But you can just use touch and then whatever you want it to be called. So we're going to do snake heading controller, and we're not going to add the py at the end of it, and that's just a practice that people do a lot of the time with Python Rust stuff. So you can see it just showed up there. We're going to go ahead and make this executable, which is sort of like an Ubuntu thing, so that we can use the /. Okay, so I went and did that. And now if I do ls, you can see it's green. Fun fact there. So we open this up, and it doesn't really know what type of file it is. So you can tell it that it's a Python file by putting that there. Okay, if I close this and reopen it, I'm willing to bet that it'll figure out. Okay, so now it knows that it's Python. That's kind of neat. Oops. Okay. So we're going to go ahead and get started. You would put a doc string at the top there. Okay. So now we're going to sort of lay out the groundwork for the file. And again, I'm really just following along in the document. So feel free to pull that up on the side if you want to see everything in multiple formats. So if you're familiar with Python, this part here is going to be really straightforward. I'm creating a class, calling it snake heading controller. I'm having it inherit from object. I'm writing a doc string here. I'm going to give it like an initializing method. This is similar to a constructor if you're coming from C. And I'm just going to write pass here because I don't actually know what it needs to do yet, and I will worry about that later. That's a practice that I really like doing. Okay, and then this part here, if you're not familiar with Python, is going to look really funny. But basically, this is saying that if you execute this file as a script, or if this is the main thing being run in Python, like this is your initial thing and it's not being included, this is going to run. So this is sort of like the, okay, I'm forgetting what in C, okay, this is like the main method in C. But this is just saying, if this happens, I want to go ahead and just instantiate my snake heading controller. And I think okay, I didn't put any semicolons anywhere else, but you might catch me doing that. And those don't belong in Python, as you very well know. And I'm just going to demonstrate one thing here in the terminal. You can run snake heading controller and it'll let you run it and nothing will happen. If we wanted to, we could just put a little thing in here. And we can do the pretty standard hello world. Okay, so now we're going to get into more of like the ROS specific things. So most of the time, I just keep like an existing piece of software that I've written pulled up on the side just to sort of copy and paste this stuff in. Or if you Google it, you can find an API. But really, you just have to remember that anytime you work with ROS, you have to like put this stuff in at the start of it. And then I have to go ahead and tell it to. Okay, so what's happening here is we're importing ROSPy. So that's ROS, specifically the Python bindings, so that everything will work. And then we're using ROSPy and init node. So whenever I ran like that stuff earlier, whenever I did like a ROS node list, that string there is telling it what the name of the node is going to be. And this is basically just declaring to ROS that I want this Python script to be a node. So that'll give you access to all the fun stuff like publishing, subscribing, and this spin method. So this is basically an infinite wait. I think if you look at the source code for this, it just does like a wait 10 millisecond command inside of a while loop. So this is purely just like a wait until the end of time, until this node gets shut down. And then this will let you do, like ROS kind of handles some, it's not quite threading, but it's almost like threading. ROS handles some of this stuff in the background. So we don't actively need to do anything once we set up our publishers and subscribers. They'll just run in like a queue. And spin lets you handle those callbacks. So in the tutorial, we do a little demonstration here, and I'll go ahead and run it now. And everybody following along should do the same. So I'm going to go ahead and do my catkin build. You can do it from anywhere inside the package or inside the workspace once you've done it once, which is kind of fun. You can't do that with catkin make. So again, it tells us stuff has changed. Go ahead and source them. And so now that we've sourced everything, we can run these things that I talked about earlier. So we can do like run the snake heading controller. Okay, so it's upset that it can't connect to a master. So I think that's a typo in the tutorial, or no, I actually forgot. Okay, so you need to run ROS core in one of the windows, and then if you go into the other window, you can go ahead and run it. And then nothing's really happening here because again, we haven't told it to do anything.
When I try to open up the Docker in two different ones, it has a fit. It won't let me.
Are you using Docker run or Docker join?
Join. Should I use join?
Yeah, you need to use join because run will try to like launch it from scratch, and join will attach to something.
There we go. Thank you.
Yep. So I now have 3 windows open. And we can use that same command that I talked about earlier, ROS node list. And now we can see that node that we wrote just there. So we can go ahead and change that just to prove that this is working. And you can see that that's the text that shows up there. Okay, I'm going to go ahead and close out of this stuff, and I'm going to change this back. Okay, so if that worked for all of you guys, then you're good, and you're good to keep on going. Otherwise, you want to go back and make sure that like you marked it as executable, and make sure that you typed in all of this ROSPy init stuff properly. So I've been talking about subscribers for a while. We're going to go ahead and actually type them now. So the command to do that is ROSPy subscribe or subscriber. And then we're going to give it the name of the topic. So earlier, like we had those arrows and they had a little name on them. And so that's just a human readable like thing to let you know what the topics are called. So we talked about earlier how That's not how you spell snake. We talked about earlier how the snake simulator is publishing the pose of the snake on this topic. So we can go ahead and subscribe to that. And whenever we did ROS topic list or ROS node list, we saw that it was a pose array. So we can subscribe to that. And then the very last thing is you're telling it, what do you want it to do whenever it receives a message on this? To reiterate, you're telling it where to listen, what it's expecting to hear, and then what to do if it hears something. So I'm just going to write a little thing there called self.posecb. And so that's an abbreviation for callback. And all that that's saying is call a function if it hears something. And I'm going to define that function later. I'm going to go ahead and write out this one too. Okay, I see someone has to go and he'll watch the rest on YouTube. Yeah, so I'm not 100% sure if we'll get through this whole thing in one segment or if we should break it up. Whenever we hit like 8, whenever I finish this node, maybe we'll take a vote. So I did pretty much the same thing here. And we're like deciding that later on someone is going to give us a heading and it's going to be a float. So we're subscribing to that. And now, since I just kind of like made up out of thin air that I'm going to have those functions, I want to actually define those now. And it's going to receive, since in Python, everything that's like a method of the object has to start with self. And then whenever it gets called, it's going to receive the ROS message that it's subscribed to, like the new mail coming in. And I would put doc strings there, but I'm going to go ahead and skip it for time. And then the last thing, anytime like, you have new stuff, you want to go ahead and import it. So I'm going ahead and like I already know what these message types are. And so in Python, like you have the name of the package and then .message. In C, you don't need that .message, by the way. And then what you want to listen to. So I'm going to go ahead and show you guys something real quick. So if you go ahead and Google this, okay, that's not what we want. Okay, these are taking a second to load. But you can go and you can see like all of these message types that ROS has already defined for you. So I mentioned float 64 earlier, so you can click on that there. And all that this is this is a 64-bit floating point number. Yeah, so I see, Sarah, you asked what exactly are the message types. That's what I'm going over now. So this is sort of like a header file, except it's a .message because C tries to, or Python, or ROS tries not to exclusively use Python or C. So that's like the data type, and then that's the name of it. So in C++, that's a double. In Python, I'm not as familiar with Python, but I think that's just called a float. And then if we go and look at common messages, we can see even more stuff. So we've got all sorts of fun stuff. So you can see like there was a specific message for if you have an IMU, like an inertial measurement unit. So it'll measure the orientation, the angular velocity, and the linear acceleration. And like all that stuff is predefined for you. They have a fluid pressure. I'm not 100% sure whenever you would need that. Okay, they have like a battery state. So I'm just sort of clicking through these, and you guys can go ahead and do that too if you're interested. But like they already have a whole bunch of things already defined. And that's nice because you can write your node to subscribe to a common message. And then if you want, you can probably find someone else's stuff that they've already written that will publish the message you need. Or if you can publish a certain message, someone else probably has something that subscribes to it and does whatever you're looking to do. So some of the more, I'm just going to quickly highlight some of the ones that may be important for the club. Geometry messages, that's really handy. Anything that you would want to represent in like 3D space, they pretty much have it here. So you can see there's a point, so that's just XYZ. You can do a twist, which is what we were sending earlier, where it's a linear and angular part to it. And that's then using a vector 3. So that's like, yeah, so just go through these at some point maybe. Like, or if you have a specific need that you want, go ahead and Google common messages and find them. Okay, I'm going to kind of get back to this now. Actually need this. Okay, so continuing to move on. So there's another little test here that'll go ahead and run. So we're going to run ROS-core again. And something there is I just hit the up arrow and that'll do my last command. So if you ever had something really long that you wrote out, you can just hit that and it'll remember it for you. And so now if we do ROS node list, we can say, okay, so I had that test there that I don't want. I'm going to get rid of that just for the future. And that's not going to take effect immediately. We can use that ROS topic one, and we can see those two things that we're subscribed to, now they show up. And then if we run ROS node info, you can see that it's subscribing to the controller heading and the snake pose. For some reason, it says unknown type. I'm not 100% sure why it's doing that, because we should have given it the type there. But hopefully that'll just resolve itself. And then something earlier that we mentioned was, so it's like subscribing to the pose and the heading, and then it's got to go ahead and publish like the controls to the snake. So we're going to go ahead and define a publisher. And then, so that's the command that you'll want to use for that and ahead. And again, like I just go ahead and copy paste that anytime I need it. But we're telling it where to put the message. So this is the topic. And if you remember from earlier, that's what it was subscribed to. The type of the message, so a twist, I just talked about that. It's a linear and angular component. And then queue size, you can typically just leave at 1. And then we want to go ahead and import that thing. I seem to be really bad at spelling today. One other difference from what I did earlier is I'm actually saving the publisher into a private variable, whereas with the subscriber, I didn't. That's because with the subscriber, I really don't care about having access to it again. But later on, I'm going to want to have the publisher so that I can run a publish method on it. So I'm going to go ahead and just run the same thing, and we can just see that difference. And again, just using the up arrow. And so it looks like it didn't know what the type is just because it's subscribing, not publishing. But yeah, so you can see now we're publishing, and it's a geometry message and a twist. So these are just little things that you can do in order to double check that your code is working the way you want it to. Just little debugging tools. Okay, now the tutorial has you going over like the message types, and we already sort of covered that. One extra way that you can go ahead and view that is with the ROS message info. And this is just another way of accessing that same information that was available online. And so you can see it's a float 64 called data. And that might be handy if you're working with like your own internal message definitions. Like for Rocket League, like we're going to make some of our own messages. And so you can't just Google those and find them. Okay. So I'm going to continue following along with the tutorial here. So if I open this up again, so you can see that like the message type, it just has one component called data. So now we can go ahead and extract that from the message that we received. So we can say heading command. And so all that that's doing is it's just pulling out that one member. So that's going to be a float is now going to be stored into heading command. And so that's going to be, we're going to have that just in radians. And I'm going to do the same thing up here. I can go ahead and show you what this message looks like. So this one's kind of funky. So you've got like some header information, and that's like a timestamp and everything. And then you have an array of poses, and this can be of whatever length you want. And they're actually like they're including another type of message inside of their message. So you can look in geometry messages point, like we talked about that earlier. And so that's included in a pose, and that's included in a pose array. So you can sort of nest these structures, which is something people do a lot. And so you're going to have a list of all these poses, and each pose is going to contain exactly one point and exactly one orientation. However, the orientation isn't going to be encoded how maybe like you would think of it normally. Instead, it's going to be a quaternion, which is like a more advanced way of representing a direction in 3D space. So like aircraft normally use like roll, pitch, and yaw, or like if you're familiar with drones, like you kind of know those terms. And so you can like roll, pitch, and yaw, and it spins you about the X, Y, and Z axes respectively. And so one of the bad things with that representation is like if you want to point straight up, like there's an infinite number of roll, pitch, and yaw commands that you, or maybe it's not an infinite number, but there's at least multiple ways that you could represent that. So like that leads to some issues whenever you're doing things with computers. So that's why people have the quaternion instead. And so roughly what you're doing is you define a vector with X, Y, and Z. And so like that's a specific direction that it's facing. And then you have W, and you're basically like taking your thing. And so if like the direction is over there, then you're going to spin around that axis. So I just did a really poor way of describing how that works. But you could go ahead and you could Google them if you want to learn more about how they represent orientation. Or you could just take my word for it, and then we're going to use a helper method here just to turn it into a roll, pitch, and yaw. And then you can just ignore how the math behind how it works. Yeah, so that's the library that I talked about earlier, and that'll come with every installation of ROS. And so it's Euler from quaternion. And so Euler angles, that's like the roll pitch yaw that humans do a better job with of visualizing. And if you look in the tutorial, like there's an online link to find more of it. So I'm going to quickly, I'm actually just going to copy and paste the code here just to save a little bit of time. But essentially, this is deconstructing that message. From the message, it's pulling out all these components that we talked about earlier. So you've got the message, and so then you have to go into poses, and you have to find the first one because we want the head of the snake. And then you're looking at orientation, and then you're pulling out the X, Y, Z, and W. And then you're going to stick that in a tuple, and then you're going to run the command on it, and it's going to give you roll, pitch, and yaw. And specifically, we just want yaw because we know the motion is constrained to a 2D plane.
James.
Yeah.
So you said that the reason why the 0 is in the brackets, that's taking the information from the head of the snake, right?
Yeah.
So it still has the information on all the other parts of the snake?
Yes. So maybe, yeah, so I could go ahead and run that. Or like something you can use is if you go into Snake Sim, here, the README. That's not what I wanted. There we go. So you can see that it subscribes to a bunch of things and it publishes things, and all this is written down in here. And you can kind of, hopefully whatever code you're working with is going to be well documented and tell you stuff like this. So like the XY positions correspond to the location, orientation, and then for the head, that's the current segment, and then it points to the next one. Okay, and it doesn't actually say that each segment, like with the order that they're listed in. But yeah, so like 0 is going to be the head, and then 1's going to be the immediate following one, and then 2's going to be right behind that. And then as the snake gets more and more components added onto it, that array will get larger and larger.
Okay, so like if one wanted to edit this so that the snake knew to avoid hitting itself, then that's kind of how you go about that, is using multiple of those variables.
Exactly. And then rather
That's
than
cool.
looking at orientation, you could look at position.
Awesome, thanks.
Yeah, I'm going to real quick try to get my camera back in focus. Okay, maybe that'll figure it out eventually. So I think since it's already like 8:10, I'm going to go ahead and we're going to finish up some of the components to this file here, and that'll wrap us up around 8:30. And then we'll push off the rest of the tutorial until next week. So we're going to go ahead and implement the controller. And so it kind of goes through like some pseudocode of how like I was reasoning through that. So like if we have a heading command, because we may not always have one from whoever we're subscribing to, you're going to want to go ahead and calculate that error that we talked about earlier. And then once you have that error, then you want to take like the sign of it, whether it's positive or negative, and that's going to tell you whether you want to go left or right. And that's for the bang bang controller that I talked about earlier. You could also do something more complex where you use like a PID controller. And that takes into account like more advanced topics, like how closely is it, like if it's, you know, if it's really far away from the value, it's going to have a more significant jolt to get back to the center. But if it's basically there, it's going to be a little bit smoother. And so in different contexts, maybe that would be useful. But for right now, we're going to keep it really simple. So I'm pretty much just following along with the tutorial here. So we're making a private variable. I'm putting it in all caps because Python doesn't let you do constants. That's just something that C has. But basically, I want to tell other people reading this code that I want that to be a constant. So that's why I'm putting it in all caps. I'm saying like if we have a heading command, I'm going to initialize that to none initially so that we can know. I'm going to update this thing here so that now it's using my private variable. So when this gets called, this piece here is going to get updated, and now we can check from it in here. I'm going to import like another little library. This is just a Python one. It doesn't really come with ROS. Okay, so then again, going back to how the closed loop control works, first we need to know the error. So we're taking the difference between heading and self.heading command, where this is like our current value, and then this is where we want to be pointing. And the reason I'm using shortest angular distance and not just subtracting them is because the rotation is going to overlap, like at 2 pi, like 2 pi and 0 radians are actually the same thing. And so this is just going to handle that for us. And so it'll always return a value between positive and negative pi. And that's important, especially since we want the error of it, since it gives if it were to give us something greater than pi, then it would actually mean that it would have the wrong sign for what we want it for. And now I'm using the copy sign function. So all that this is doing is it's making a new variable called angular velocity command. And all that that's going to be equal is the angular velocity magnitude, which is 2.0, so 2.0 radians per second. So that's a little bit, I guess you could convert that into like RPM if you wanted to, or how many revolutions per second, but that's like an arbitrary speed that we just picked. And then we're saying give it the sign of the error. So if we're facing the one direction, make it the one that would bring us to the center. And so you could do that by like working out, the math for that, or you could just try it, and if it's wrong, stick a negative there. So I'm still kind of following along with the tutorial here. So now I'm at the publishing the output section. So now that we've calculated this number, we need to actually send it back to the ROS network. So in order to do that, we can't just publish like the message as is, because right now we just have a float. But if you remember, we need to pack it up nicely into that twist structure. So like we need to put it in this package for a twist so that it knows how to receive that information. So right now, all that we really know is angular.z. And we just need to give it some constant speed that it's going to travel at. So we can just define that here. So I'm going to go ahead and just make another constant. Again, this is going to be 2 meters per second, just a fairly arbitrary number that I just made up. You can experiment with different values and pick whatever seems to make sense. And now I'm going to go ahead go about actually publishing this message. So the first thing I'm going to do is I'm going to create a new twist instance, and then everything's going to initialize to 0 because there are 6 fields inside of it. They're all going to be 0. And I'm just going to go ahead and assign the only 2 that I care about. Oops. And then I'm going to go ahead and publish this. And now this whole file is pretty much done. So we can go ahead and run this. So there's a note about using parameters. I'm going to skip over that for now, and we can talk about it next time. But that'll let you do fun things where, like, we have these hard-coded values. So right now, if you wanted to change those, you'd have to open up the source and edit that. And that's not always super convenient. And so you can actually stick things in something called a YAML file. And so that's like a practice that people use a lot with ROS. So I'm going to skip over that section, and we'll worry about that later. It also talks about creating a launch file. And again, I'm going to skip over that, and we'll talk about it later. So let's go to the part where we're actually going to go and test this. And then this is sort of an incentivizer for why you might want to create a launch file in the future. Actually, I don't want to run that exactly as is. So I'm going to go ahead and do ROS launch. And I don't remember exactly what I want. So this is a new window, so I need to source everything again. Let me check one thing here. Okay, I'm not 100% sure why this isn't rendering. But we can go ahead and just ignore that for now, and I'll give an update on how that works at the next time. I can try that there. There we go.
Could it be that you're doing snake node and not snake controller?
There was an underscore that I put in there by mistake. So specifically, I'm just trying to run. I don't want to. The reason I did that is the snake sim.launch. So we'll go over launch files at a later point, but it includes a lot of other stuff here. So it's going to run the like the RQT steering part, and it's also going to run yeah, like the robot steering here. It might run RViz. It's going to do all this stuff, and I don't necessarily want to use all that. I just want to run like the snake simulator, and we'll run our own controller. So the command for that, it took me a second to figure out, but you're going to do ROS launch snake sim snake underscore node.launch, and then you can go ahead and pass in a parameter, which is kind of nice. Use pygame, use underscore pygame, and then do a colon equals false, and then that'll make sure that it renders for you. So right now that's waiting for someone to tell it what to do. So we can go ahead. I'm going to open up yet another window. So you can see that we only have the one node running, which is the snake node. If I run that, you can see we still have a couple of topics, but nothing's really subscribing to anything. So I'm going to go ahead and run the node that we just created. So the command there was catkin build, and then source it if you haven't already. So I can go ahead and source that again. And then you're going to do ROS launch, sorry, ROS run, because we haven't made a launch file yet. So you need to use ROS run. And then the name of the package is going to be, I think we called it snake controller, and then snake heading controller. And the reason, oh, that's exciting. The reason I got rid of the .py is just so that whenever you run that command, you don't have to stick a .py there, because whenever you compile things with C, it's not going to have that, and it's just a little bit nicer. So we can see that I've made an error here. So I'm trying to subtract off the heading command even whenever it doesn't exist. So go ahead and add that line if you haven't already. And then with Python, it's kind of cool that you don't need to rebuild, because it's really just creating a link to it and like telling it that it's there. And it's not like C. Now we can double check that it's running by using ROS node list, and there it is. So that's cool. We can use a ROS topic list, and we can see that now controller heading is a topic that exists. We can also do ROS node info, or heading controller, yeah. And we can see that, you know, these things earlier, like it didn't know. So heading, it still doesn't know the type, but now that somebody's publishing snake pose, it knows that it's a pose array. So if we pull up the snake, like it's still not moving. And the reason for that is that if we look at the code, like the pose callback gets called at like 30 hertz or something like that. We can actually double check that. ROS topic hertz. So you can see, yeah, that's running at 30 hertz. But because we haven't given it a heading command, it's not doing anything yet. So we can publish that, and there's ways to do that with a GUI, or there's a way to do it just through the terminal. And I think it's always nice with ROS to know both ways. So I'm going to show you the terminal way first. So ROS topic pub, and then you can just hit tab there if you don't want to guess what the messages are, and it'll tell you. And again, I just had to type out the first couple letters and hit tab, and it knows. And I just hit tab again, and it does all this cool stuff for me. So this is using like a standard angle convention where to the right is 0, straight up is pi over 2, to the left is pi, and then down is, pi, and then like the standard, you know. And so I'm going to publish 3.14 because I want it to go to the left. And it didn't seem to do anything there. We'll see if something crashed. Okay, is anyone in the comments, am I doing something really stupid here? Okay, so this is a really cool demonstration now of whenever something doesn't go properly in ROS, how you can go and try to debug it. So I'm going to show you one of my favorite commands, ROS WTF, and it's going to do like an automatic analysis of everything and try to tell you what's happening. And you can guess what that acronym stands for. And so you can see that it found one error, that the ROS database isn't updated. That doesn't really matter. But now it did find a warning, and this actually looks like a pretty important one. It says that the following node subscriptions are unconnected. Snake heading controller, controller heading. So that's funny because I tried to just publish something to it now, but apparently it's not connected. Okay, so it appears to be connected now that I've had it run at a certain frequency. So again, we can run RQT graph to try to figure out why things aren't working. So if we zoom everything forward, zoom everything in, we can see that we have our ROS topic command. Okay, it's being a little bit latent and it's hard to kind of zoom in. So we're publishing controller heading, that's going to the heading controller. That's publishing the commanded velocity to the snake. And then that's sending back the pose. And so something here isn't working. So again, what's some stuff that you can do? So we can ROS topic list. And then what you can do is you can ROS topic echo. So let's do controller/heading. And so, okay, so you can see that we're publishing data there. Why don't we, it's supposed to be sending something on snake command velocity. So let's go ahead and see if that's working. Okay, so now if we look at this, we can see the problem. So it's not publishing, so it's publishing like an angular velocity, but there's no linear velocity, which isn't great because otherwise it's not going to move. So we can go ahead and I can go ahead and look at my code and I can see that I actually had a minus sign instead of an equal sign in that one spot. So that was a completely accidental demonstration on how to do some debugging inside ROS. But hopefully you found that interesting. So you can see we tell it to go pi, and that's exactly to the left, and it's just going to run into the wall and then die, which isn't super exciting. We can give it other commands. So why don't we reset it? And now something kind of bad here maybe is that we just have it remember the previous command. And if we give it a new one, if we're not giving it anything, it just remembers the last one. So that may be something that you want to fix in the future. But you can see like this is it functioning. I'm going to show you one last way just on how to run it with a graphical tool, and then we'll finish off for today. So there's this cool tool called RQT GUI. You can open it up, and then we'll go into plugins. So we want to go ahead and there's topics, message publisher. So we're going to send to controller heading. It's a float, it knows that. You can go ahead and hit plus, and now it's going to be there. You can hit a check mark to enable it. And then what do we want the expression to be? So let's put in like 5, and I think that'll be somewhere in the bottom left, or I guess a little bottom right. So now we can go ahead and rerun that, and now it's remembering the other command that we just gave it. So we can give it something else. And let's say that we want to change it. And so maybe if I were fast enough, we could prevent it from crashing into itself, crashing into the wall and dying. But evidently I'm not. Yeah, evidently I'm too slow. But this is, if you want like a graphical tool for doing things, this is one that you can use there. And there's plenty of other things that come along with it, like plugins. We can look at topics. And there's probably a subscription one. Yeah, like there's Topic Monitor. So if we wanted to, we can look at score. And this is just doing the same thing that ROS topic echo and Hertz is telling you. So there's lots of good debugging tools in ROS that you'll want to get familiar with. Okay, so I'm going to sort of close off the recording here since we're now at 90 minutes. And so evidently I rambled on much more than I was planning on. But hopefully like going really in depth into some of this stuff was really helpful for you. And if people are interested, I can do the same thing next week where I basically just take a chunk of time and just try to talk about ROS as much as possible while going through the tutorial. Or if this is enough, you can use this as sort of a starting point, and really you should have everything you need to keep going with the tutorial now. So we can go ahead and close everything off. Inside the Docker container, you can go ahead and just hit Control D, and that'll exit out of it. And then all of your files here still exist because they're saved to both of them because it's using a bind mount, so you don't have to worry about that. But if there are any questions, I can answer them now, or we can go ahead and finish it here.
I had a quick question on, can you hear me, by the way?
Yeah.
So I had a quick question. It's a little behind this. It's installing the WSL2.
Okay.
I've gone through multiple tutorials. I've tried a whole bunch of stuff. I've upgraded my entire Windows. And so I was about to go into the BIOS to try to get the visualization to work. But I guess I was wondering if you've seen the error, the virtual machine could not be started because a required feature is not installed when I try to install the Ubuntu.
I have not seen that, but that sounds like something with Windows Update maybe. But it seems like you've gone ahead and done all of those steps. So maybe we can try to figure that out more if you post some more information in Slack. Okay.
Yeah, I can put a post together. It's starting to get to the point where I might just get an external hard drive and set it up on there, because this is just getting kind of ridiculous. But yeah, I'll make a post and I'll put some screenshots in, and then maybe someone else has run into that problem before.
Okay. Yeah, and with your note about getting an external hard drive, or if you want to dual boot, that'll definitely give you a better experience. Because WSL, as amazing as it is, it's still a pain in the butt sometimes.
Okay, sounds good. Thank you.
Thanks, James.
Yep.
That was actually your tangents were actually really helpful because I had gone through the tutorial before, but I didn't really understand what I was doing, just kind of how to do it. So you going more in depth as to what exactly everything is doing was very, very helpful and informative.
Okay, awesome. I'm glad that that wasn't just me rambling on, and that was actually useful.
Yeah. Thank you very much.
Yep.
All right. See ya.
See ya.